Welcome back. We are working on our Algebra 2 Sequence and Series Lesson Number 4, Arithmetic Series Homework Review, Part 3. Please make sure you catch Parts 1 and 2. And today, for Part 3, we have question number 5. For an arithmetic series that sums to 1,485, it is known that the first term equals 6 and the last term equals 93. Algebra determine the number of terms summed in this series. Well, for this one, we're just going to use our formula and we'll solve for our n value. And so again, our formula is S of n is equal to n times a1 plus an all over 2. And so we have the sum, which is 1,485, is equal to n, we don't know. We do know the first term is 6, and the last term is 93, and we'll divide this all by 2. So we have combined the 6 plus 93 is 99, so 1,485 equals n times 99 all over 2. Now what we can do is we can kind of cross multiply here and multiply the 2 times 1,485, and we're left with 99n on the other side. Okay, and so when we multiply 1,485, I think it is 0 here, 16, 17, and then carry the 1, that's going to be 9, 2,970 is equal to 99. N. Now we'll divide both sides by 99. So 99 goes into 2,970. You're like, well, just use a calculator. Sometimes I like doing this way. So we'll use 3. All right, so that's a 7, because 3 times 9 is 27, carry the 2. And then 27 plus 2, hey, look at that. And that works out nicely. So our n value, the number of terms, is going to be 30. So n equals 30 for number 5. Number 6. Arlington High School recently installed a new black box theater for local productions. They only had room for 14 rows of seats, where the number of seats in each row constitutes an arithmetic sequence starting with 8 seats and increasing by 2 per row thereafter. So that means in this case the first row would have 8, the next one would have 10, the next one would have 12, and that's in this case, so the first row has 8, second row has 10, third row has 12, and we're increasing by, it says 2 seats, so it's kind of almost a auditorium, if you will. Now, how many seats are there in the black box theater if there were 14 rows? So we could list them all out, but we do know that we can figure out the number of seats in our 14th row by using our formula. A sub n is equal to a1 plus n minus 1 times d. Now, we know in this case our first number, a1, is going to be 8, because that's the number of seats in the first row, okay? Starting with 8 seats. Okay, so a1 is 8. Our common difference is going to be 2. Increasing by 2 seats, so that's our common difference per row. And so n is equal to 14, because there are 14 rows of seats. So the last number of seats in the last row would be 8 plus 14 minus 1 times 2. So we get 8 plus 13 times 2, which is 8 plus 26. The number of seats in the last row is equal to 34, because 8 plus 26 is 34. So we now have the number of seats in the last row, we have number of seats in the first row. Let's use our formula. So S of 14, because that's 14 rows, we'll have in this case n is 14 times a1, the number of seats in the first row, plus the number of seats in the last row, all over 2. So S of 14 is equal to 14 times 42, I believe it is, right? Over 2. Well, you can divide 2 into 42 to get 21, or you could divide the 17 by 2 to get 7, 14 by 2 is 7. And so now we're going to multiply 21 times 14. That's 84. Okay, drop to 0. 21. We get a total of 294 seats. So, number of seats in the theater is 294. Okay, so here again, one of those problems where we want to find the last term. Now, you could have, if you want to, kept adding 2 to your 14 rows and add them all together. That works out to you. It's just not so efficient, I think, in this case. Okay. Number 7. Simeon starts a retirement account where he will place $50 into the account on the first month and increasing his deposit by $5 per month each month after. If he saves his way for the next 20 years, how much will the account contain in principal? So we see our first amount placing in there will be $50. That's our A1 value. Okay, and increase the deposit by $5 per month, which would mean in this case we have almost like an arithmetic sequence because every month he's adding $5. So the principal, now we're not including the interest that he might get though, just in principal, which is how much money he is physically has put in there. This is over 20 years. Now the thought is n 20? No, because n is equal to 20 times 12. The reason is we're doing $5 per month in each month after. So we want to figure out how many months have passed. So that would be 20 times 12 is 240. So we could add 5 constantly over and over again, add them all together, all right? But that's what we figure in this case that his deposit increases by $5 a month. So it's not that he's adding $5 every single time. That his second month he's adding 55, and the third month is adding 60, and so on and so forth. So it might be a little bit more challenging to list everything out. But instead, we can find out what his final deposit is after 20 years. And so we would have to find, in this case, the deposit of A of 240, which we don't know, but we can find out though. Because first, again, the formula we're going to use in this case of A sub n equals A1 plus n minus 1 times D. And again, D is the $5 added every single time. A1 is 50, so we have 50 plus 240 minus 1 times 5. So we're going to get, in this case, 50 plus 239 times 5. Okay? And so if you multiply 239 times 5, we're going to get, in this case, 1,195. So you have 1,195. Add 50 to that, we get $1,245. That's how much the 240th deposit will be. So Simeon deposits his last deposit at the end of 20 years will be $1,245. How much will he save up in principal? Well, so the sum after 240 deposits is equal to 240 times the first term, which is 50, plus the last one, which is 1,245, all over 2. So that means you have, so 240 is equal to 240 times, in this case, you add 50 to 1,245, becomes 1,295 over 2. Now you can divide this and make this 120. I try to simplify things a little bit. don't have to. So we're going to take our 1,295 and multiply by 120. We will see in this case that the total amount that we deposited will equal to $155,400. And that's the total amount Simeon would have deposited into the account after 20 years, following this pattern of 50 for the first month and then increasing his deposit each month by $5. Okay, ladies and gentlemen, this will be the end of our Algebra 2 Sequence and Series, lesson number 4, Arithmetic Series, Home Review, Part 3. If you found this video helpful, please give it a like, and if you have not done so already, subscribe to the channel and turn on notifications, hit the notification bell so we learn when new videos are added to the channel. All right? And leave any questions or comments in the comment section below. We'd love to hear any questions you have in case any of these are maybe errors, because I sometimes make errors and all, but also in this case if something is not very clear. All right? Thanks so much for watching. Look forward to seeing you in the next video. Take care and be safe.